Hey guys, I have to do a couple of different videos for today. My apologies for that. This is the first video, which covers the back of your notes that we started in class. We're talking about linear and angular speed. One of the biggest applications of knowing the angle measures is that if you consider that you have a particle that moves at a constant speed along a circular arc of a radius, then you can find two different speeds about it. You can find the linear speed, or you can find the angular speed. Clearly in here, I am giving you two different formulas. These two formulas are formulas that you will need to know. But the most important part is that you understand that the linear speed measures how fast the particle moves, while the angular speed measures how fast the angle changes. If you consider a clock, you can find the speed that a particle at the very tip of the second hand or hour hand or minute hand is moving along that clock. You can find two things about it. You can find how fast is or how much distance does the tip travel, and you can also find how quickly does the angle change. So let's go ahead and look at an example. If you think about the second hand of a clock, which is 10.2 centimeters long, we have to find the linear speed of the tip for this second hand. Well, to find the linear speed for the tip of the second hand, we would have to use the formula that linear speed is equal to the arc length divided by the time. Well, now we have to go back and find the arc length. To find the arc length that the tip of the second hand travels around, we're really looking for the circumference that it travels on. The arc length from earlier we saw is equal to the radius times the angle theta. The radius is given to us as 10.2 centimeters. Well, what is this angle theta? I do know that the second hand travels all the way around the clock. So I do know that it makes a full revolution. This will be my angle theta. The full revolution has to be measured in terms of radians because theta is always in radians. So that gives me 10.2 centimeters times 2 pi. That gives me a total arc length of 20.4 pi centimeters. Well, I also need to know the time. How much time does it take for the second hand to complete a full revolution? It takes a minute, and that minute is equal to 60 seconds. I think we are ready to find that linear speed, guys. The arc length S is equal to 20.4 pi centimeters, and then the time is equal to 60 seconds. I had to reach out for my calculator. I hope you guys attempted that also. So our linear speed adds up to 1.07 centimeters per second. Well, that kind of makes sense, that it's not exactly 1 centimeter per second. The bigger our clock gets, the more speed the tip of that second hand will travel. The smaller the clock hands, if we try to do that for a little watch, then it's traveling a lot less than a centimeter per second. The remainder of the notes will be at a separate video. Just a quick reminder, you do need to complete any missing problems at the front. And I also want you to complete any missing problems from the other worksheet that we did in class. Let me switch back and just show you which one it is. Any missing problem from this worksheet also should be completed. On the back, we didn't do any of the conversions, but now that I do believe you feel more comfortable with the converting, I want you to try them. Please do not skip over question 23 and 24. I will be collecting this activity tomorrow. When you come to class, please make sure you bring it. Okay, guys, I'll be back for another video.